if the person has this Clostridia problem when they're taking a common drug, acetaminophen, one of the common forms of acetaminophen is Tylenol. Acetaminophen, Tylenol is here right in the middle, and there's 4 different ways that acetaminophen can be detoxified. It can have a sugar called a glucuronic acid attached to it, and this process is called glucuronidation. It can be have a sulfur atom attached to this hydroxyl group here. So remember that acetaminophen is a phenol, so it's detoxified by a phenol sulfotransferase. Rosemary Waring and her research group showed that this pathway is defective in autism. So the individual with autism may not be able to convert acetaminophen to form a non-toxic metabolite very well. But in addition, this pathway is blocked by the number of the Clostridia metabolites. So if the person has Clostridia problems, already has a weak enzyme for detoxification, then the acetaminophen may form more toxic compounds, and one of the most toxic is called NAPK. It's a long name. I'm not going to repeat it, but the NAPK is the abbreviation of this very reactive compound that is extremely toxic. Or the body can detoxify acetaminophen to form aminophenol, which can react with omega-6 fatty acids to form a cannabinoid, which also has the ability to alter behavior. So because of inhibition, because of the presence of Clostridia bacteria, they block this reaction. There's a greater chance that they will convert to form much more toxic products from the metabolic transformation. So the NAPK has the ability to combine with and deactivate multiple proteins. Having a sulfhydryl group, it can cause liver damage, and if the amount of NAPK gets too high, it can cause death. In addition, the NAPK uses up glutathione, so glutathione is not available for detoxing other substances. Remember, the dopamine itself, which is going to be higher if you have the Clostridia problem, is going to be using up the glutathione as well. So you have 2 different processes that are using up glutathione. If you have other toxic chemicals you've been exposed to, like mercury or polychlorinated biphenyls or DDT, all of these detox reactions will be impaired because glutathione is not present in adequate concentrations. So this is showing the concentration. If you have the Clostridia, this is blocked. You have increasing conversion to more toxic. So and you may also have conversion to the increased conversion to glucuronide, but a lot of young children are also deficient in this pathway. So if there's deficiencies both here and here, the only way to detoxify is by going to these more toxic routes of metabolism. So when you have Clostridia, especially when it's at very high concentration, it produces these excess phenolic compounds, the HPHPA and 4-cresol, as well as another one I mentioned, the para-hydroxyphenylacetic. These block the conversion of dopamine to norepinephrine, so there becomes excess amount of dopamine, and dopamine is a very reactive neurotransmitter that forms free radical oxidative type of compounds, and that can be very damaging to the brain in excess. And at the same time, acetaminophen also forms these highly reactive toxic compounds, and NAPG being one of the most important. Both of these have a severe negative effect on the brain, and so in effect, this combination could be considered the atomic bomb of drug toxicity in the brain, having two different substances that are very toxic, both being produced together, and each one, the NAPG blocks uses up the glutathione, and so it makes the dopamine more toxic, and vice versa. So each of the pathways makes the other pathway more toxic.